Welcome to the Housing Consultancy Services. This is Alex, Illyria, and Gab. How may we assist you?
I'm Carl Fredrickson, and I would like to consult for this house that I am planning to build.
Indeed. Then you have come to the right place. May we know what plans you have for this house you plan to build?
I want to make our house float, using balloons, that is. By tying thousands of balloons to our house, I plan to travel to the Paradise Falls in South America. It is actually my wife's dream before she passed away. That is why I intend to fulfill that promise.
That is an amazing plan, Mr. Fredrickson. But as grand as that plan sounds, there are a lot of factors that needs to be attended to before making that plan a reality.
At most, it would need 100,000 to millions of balloons to float a house depending on the weight of the house, Mr. Fredrickson. Aside from that, there is also an issue of the balloons deflating before you can even reach your destination. One of the factors would be effusion.
That is true, Mr. Fredrickson. If helium is inside the balloons, it would deflate faster because the molecules are smaller. Light helium atoms effuse through small holes in the rubber. Thus, molecules can constantly escape at a rate that increases with the difference in pressure between the inside and outside environment. As a result, leakage is greatest when the balloon is freshly inflated and decreases as air escapes.
Oh, is that true then? But why does that happen?
Well, let's rewind back and talk about Thomas Graham. He was the one who formulated Graham's law, and his contribution played a vital role in the development of the atomic bomb.
According to Graham's law, the rate of effusion of gaseous substance is inversely proportional to the square root of its smaller mass. Recall that gas is a state of matter that has no fixed shape and volume, where it conforms to the shape of its container. Molar mass, also referred to as molecular weight, is the sum of the mass of the substance per mole. We already know what gas and molar mass are. How about effusion?
Effusion refers to the movement of gaseous atoms or molecules from a container to a vacuum through small openings. For instance, after inflating a balloon with gas, it will slowly shrink after some time. This is because the gas molecules present in the balloon escape through its pinhole.
Another example is when the vehicle's tire loses air, which sometimes turn it into a flat tire. This means that in effusion, air pressure drops over time, even in a properly sealed tire.
Remember that the lighter gases pass through the small openings faster than the heavier ones. For instance, a balloon filled with helium deflates faster than a balloon filled with carbon dioxide.
The rate of effusion refers to how fast a gas can escape from a container through a hole.
If the temperature and pressure of two gases are the same, the ratio of their effusion rates is inversely proportional to the square root of the masses of their particles, where A and B represent the two types of gas, and M refers to the mass.
To demonstrate the rate of effusion and its relation to molar mass, we have prepared a sample problem for you, Mr. Fredrickson.
For example, it states that if the molar mass of helium is 4 grams per mole and oxygen is 16 grams per mole, calculate the ratio of the rate of effusion of helium and oxygen.
From Graham's law, we can produce this equation. Rate of effusion of helium over the rate of effusion of oxygen is equal to the square root of the molar mass of oxygen over the square root of the molar mass of helium.
Then, we substitute the values to its corresponding variables.
Therefore, helium effuses twice as rapidly as oxygen.
If you notice, helium has a higher effusion rate because it is lighter than oxygen. Lighter particles move faster than heavier ones.
Well, for now, I shall thoroughly think about my decision.